Hello, so this is a video for the notes on graphing with vertex form. It's also uh, an explanation of how you can use patterns in the y values to easily plot these quickly, both in vertex form and in standard form. So first off, let's review what is a parent function and what is a vertex form. So again, we are dealing with x squareds, so f of x equals x squared or y equals x squared. So that is a quadratic equation. The graph of it is a parabola, okay? And parent functions, when we talk about this, okay, are just the basic form of any function. So y equals x squared, y equals x to the third, all parent functions. So this vertex form can actually be used on any of the parent functions. The h, k, and a all operate the same for any function that we deal with. So the parent function for x squared, remember, it's just the set of points. So, 0 squared is 0, 1 squared is 1, negative 1 squared is also 1. Remember that when you square something, it's always positive, and that these points in here, so this 1 and this 1, they're repeating, okay? So they repeat because the graph of y equals x squared, or the quadratic, is symmetric. And then if we plot these points, you'll notice that those points, are cut right down this blue line right here. And that blue line is called the axis of symmetry. And the shape of this graph is that U, that is the shape of the parabola. So what is the vertex of any graph? That vertex, okay, is the highest or lowest point. You can also think of it as the point where the graph changes. So if we go back to this graph, it is falling. It's going down until we hit this vertex. And then it starts going back up. Okay. Now, for a cubic function, that it comes up and then keeps going up, but it has this like small little point, where it changes direction a little bit. So the vertex can also be phrased as where the graph actually changes direction. So in this case, that vertex is 0, 0. With all quadratics, they do not have endpoints. Okay, it doesn't have an endpoint. It's infinite. Okay, it is a continuous function. Okay, and we already talked about it. What does symmetry mean? That the values are going to repeat. It's going to be like a mirror. Okay, so in this case, remember that it says equation of the line of symmetry. Equation means we need an equal sign, okay? And it's always written x equals 0. It always comes from the x value of the vertex, okay? So in this case, this one has a minimum. So remember, the minimum is the lowest value. Maximum is the highest value. So you can always where the vertex is, if it's the lowest point or the highest point. So what are the key points that you need to know for any quadratic function? Okay, you need to know the vertex. You need to know the axis of symmetry. When you're graphing in standard form, you want the y-intercept and at least 2 corresponding points, using the axis of symmetry to kind of reflect those. That's how you get those 2 points. So there is a pattern that helps you graph these. So it's a pattern in the y values. So I put 2 functions here, okay, y equals x squared and y equals 2x squared. And let's examine those patterns. So first off, we have seen these before. So then I just added in 4 squared and 5 squared, which is 16 and 25. Now, if we take that same value and we say, okay, what is y equals 2x squared? Well, 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. okay? And then 2 squared is 4, times 2 is 8, 18, 32, and 50. So the big thing with this is having these tables. Now we're going to examine what is going on in this. So let's first look at these x values. So these x values, they're just going up by 1. So, right, they're just a difference of 1, okay? So that's the same for both of these. And that is the key to this, is the x values are just going up by 1. Let's look at the y values. So the x squared, so you notice from 0 to 1, okay, it went up by 1. And then 1 to 4, it went up by 3. 4 to 9, it went up by 5. 9 to 16, went up by 7. 16 to 25, it went up by 9. And it's the same on both sides. So what you notice about these, okay, is that this difference is just 2 each time. So 1 to 3 is 2, 3 to 5 is 2, 5 to 7 is 2, 7 to 9 is 2. So if I want to do the next one, I would add 2 to this, so it's going to go up by 11, so it's going to be 36 up here. Let's look at the 2x. 0 to 2 is 2, 6, 10, 14, 18. So what I want you to notice is the relationship between these two columns. You'll notice that each time these numbers times 2 are these numbers. So the only difference between here and here is this a value. That a value affects this pattern. And for every quadratic, this pattern is consistent. So if you notice in the first column, the y values are in the pattern of 1, 3, 5, 7, 9. Those are all the odd numbers, okay? In the second column, it's 2, 6, 10. It's always, okay, the next odd number times 2, okay? So the rule for this is if the x values are counting by 1, the y values follow a 1, 3, 5 pattern times the a value. So the a value in this case, in the previous one, was 2. So I just took the 1, 3, 5 pattern and I multiplied by 2. If it was a 3x, I would multiply by 3, and it would be a 3, 9, 15 pattern. And it helps me easily plot those points quickly when I am graphing these. So let's look at this. So how does it help us graph? And that is the biggest thing. So this is our quadratic. It is written in our vertex form. So it automatically tells us what the vertex is. The vertex for this is 4, -6. Okay, my h and my k. All right, so I'm going to actually take this point and I'm going to put it at 4, -6. All right. My axis of symmetry, just to remember, is the equation. Okay, it is going, if I look at the a value, okay, it's going to open up, okay, because the a is positive. Okay, that means it has a minimum. All right, the minimum value for this is going to be -6. It's the y value. Okay, and my y-intercept, I'm actually going to skip this right now because that more comes in when we have the standard form. So how does that 1, 3, 5 pattern help us plot the rest of these points? So when I go over by 1, I know my next point is going to go up by 1. So I can actually plot those. Now, going from the over here, if I go over another one, my next point is actually going to go up by 3 because it's not that consistent linear function. Remember, it goes 1, 3, 5. Okay, so if I go over another one, now I'm going up 3 points. 1, 2, 3. And I have that point there. And I'll move me over. And I have, again, I go from this point, I go over 1 and then 1, 2, 3. Okay, and now I can actually draw my parabola right here. So it goes down and then goes up. Okay, so another example of this. Okay, again, vertex. Okay, this was a trick question. Okay, because there's nothing in these parentheses, so it's 0, 2. All right, my axis of symmetry is x equals 1. Because this is negative, now it's going to open down. It's going to have a maximum. Okay, that maximum point is going to be 2. Okay, and again, I'm going to just cross out this y-intercept. So, first thing I'm going to do is I'm going to grab a point and I'm going to plot the vertex 0, 2. Okay, now that 1, 3, 5 pattern. Okay, so 1, 3, 5 pattern is going to help me, but it's not going to be a 1, 3, 5 pattern because I have a is -2. So I have to take each one of those and I'm going to multiply by -2. That's going to tell me how to count. Okay, so instead my point becomes, so I'm going to go over 1 and then -2, -6, -10. Okay, that means I'm going over 1 and then down 2, over 1, down 6, over 1, down 10. So I take the point. I go over 1, down 2. On the other side, I do the same thing. Then my final point that I'm going to plot, because I don't need tons of them, I go over 1, and now I'm going to go down 6. I'm going to go over 1, down 6. Now you'll notice that this graph is now opening down, and it is steeper. Okay, like that. Now, what everyone loves are fractions. So, just to do this, remember my vertex is going to be -5, -3. This is going to be x equals -5. My a value here is positive, so it's going to open up. It's going to have a minimum. Okay, my minimum value is going to be -3. So what I'm going to do is I'm going to plot points. So first step I'm going to do is I'm going to plot my vertex. So my vertex is -5, -3. So -5, -3. I'm going to plot that point right there. Okay, I'll try and make that nice and big. All right, so now, all right, that 1, 3, 5 pattern is going to be affected by this 1/2. So instead of 1, 3, 5, now I multiply by a half. So I'm going to take half of those. So this is kind of the tricky one, okay? Because students sometimes don't like fractions. But what I'm going to do is I'm going to go over 1 and then up a half. Okay? And it's going to be in the middle of that box. I'm going to go over 1 and up a half. Then from that half, I'm going to go over 1, and I should have gone up 3, but instead I'm going to take half of that. I'm going to go up 1.5. So there's a half, and there's another 1. Okay, same thing. Over 1, up 1.5. There's my parabola. Okay, and I can then draw it in like that. Okay. Now, the pattern also helps us write the equations. So writing the equations is all about locating the vertex and then being able to figure out that pattern, that first step that they do. So in this case, I have a graph, okay? I need to find H and K. H and K is right here, all right? So H, all right, is going to be -2, -1, okay? So my H, remember, is always that opposite sign. So this becomes a +2 here, and then my K becomes -1. Now I have to figure out what my A is, okay? So those two numbers came from my vertex, all right? Now my A, I start counting, okay? And you only have to really count once. I go over 1 and then up 1, over 1 and then up 1. And then if I continue, I can go over 1, up 3. It's following that 1, 3, 5 pattern. So my A here is 1. Now, if I repeat the same process, here, you'll notice that it's going down. All right. So again, I locate my vertex. Okay. My vertex is right here. Okay. It is at 2, -4. So now what I'm going to do is I'm going to write this as -2, -4. Remember, 2 is a movement to the right. All right. Now what I do is I count. 1, I go over 1, and then I went down 3. So this A value now becomes -3. And now I've written the equation. So now that is in my vertex form. In here, again, locate your vertex. So my vertex is -5, 2. So -5, that moves it to the left. +2. And now I have to count for my A value. Over 1, and then up a little bit. Now this is where you have to estimate. So is that up a little bit in the halfway point? Is it below it? Is it above it? That sort of thing. So in this case, it's below a half, I think. All right. So what I would do if I was doing this problem, I wouldn't say it was a half. I'd say probably it's a quarter. You could even say it's a third, that sort of thing. So that's how that pattern helps you write the equation, by just counting and thinking of it as that slope. Please email me any questions if you have any, and thank you.